This is the first of two videos to discuss the last two forms of descriptive statistics, which are measures of variation and measures of dispersion. Again, as we discussed, there are four categories of descriptive statistics. The first is summaries of data, that's your charts and graphs. The second is measures of central tendency, that's your mean, median, and mode. The third is what we're going to start with in this video, which is your measures of variation and dispersion. Then you have to watch the next video to see measures of position. So like I said, this can be called either measures of variation or measures of dispersion. And really what that has to do with is how scores vary, hence the term dispersion or variation. There are three general statistics that are associated with measures of variation. They are range, standard deviation, and variance. Now, range you've probably all done. That's nice and easy. High minus low. That's the easiest calculation. Everyone does it. Doesn't give you a ton of information, but it can give you some basics. Standard deviation and variance are strongly interrelated, so we're going to spend a lot of time going through them because they are a tricky concept. Just in definition, standard deviation and variance really have the same definition. They're both a measure of variability among scores about the mean, or essentially what they are is the average variability of your scores in a sample around the mean. However, they have one major difference. Standard deviation is measured in the unit of measure of the variable, so centimeters, or seconds, or percentage points, where variance is measured in the squared unit of the measure, so centimeters squared, seconds squared, or percentage points squared. To figure out how to calculate standard deviation, you have to calculate variance first. So the basic concept is how scores on average vary about the mean. So logic would say that if you subtract each x individual score from the mean, then you sum up those differences, you should get, and then take an average, so divide by n, you should get variance. But there's a major problem when that happens. If we, in this first column over here, all of our x scores, if we subtract them from our mean of 71.5, and then we sum up those scores, we get a 0. Well, if we divide anything by 0, we're just going to get 0. So according to this, the variance is 0, or the variability is 0, but if you look at these scores, 65, 66, 67, 68, clearly there is variability. So mathematically, just subtracting scores from the mean is a problem. And the reason is because the sum of the variation scores, because the mean is the fulcrum point, and the sum of those differences, so x minus the mean, will equal 0 because you're balancing off positive and negative values. So we can't just do x minus the mean in order to calculate variation. How do we get rid of this issue? We square the differences, because we know that whenever we multiply a negative by a negative, we're going to get a positive. If we get rid of all the negatives, the math becomes easier. So now the formula gets altered just a little. We're still going to do x minus the mean, but we're going to square those differences. So you can see here, I did x, now I subtract it from the mean, then I squared the differences. Then we summed that value up. So I'm going to take the sum of those values, and that's going to get me a statistic that I call total variance. It's the sum variance, not the average variance. So as we see here, a negative times negative gives you the positive, so we no longer have a sum of 0. Now, the sum of the squared values represents the smallest possible value of variability that can be found in this data set. Why? Because if we use any other value or mean to take away those negatives, then the sum would not equal 0. So once we square these values, the sum would be larger. This principle is called the sum of squares principle, and it's a pretty important one to understand. So going over this component, the idea that there is no other way to alter that data so that the initial data set, if you were to just subtract from the mean and sum up, would equal 0, and therefore when you alter it, it would also it would create a larger variability than is actually there. So how do we calculate variance? First, we saw before, we take the square of each x minus the mean value, not just x value here, let me correct that. That's x minus the mean value. We take the square of that. We sum up those squared values. We divide by n minus 1, where subtracting the 1 from the sample score is an adjustment for sample size, and then we get variance. Consequently, variance is calculated in those squared units we talked about: centimeters squared, points squared, seconds squared. So here we have our scores again. We have our summed up value of 204.5. If we divide 204.5 by our sample minus 1, so n minus 1, which is 10, we get a variance of 22.72. Now, this is an example of percentage points because these are scores on an exam. So the 22.7 is the average variability in percentage points squared. It's not a very helpful number to the practitioner. Practitioners don't want to read about percentage points squared. Teachers want to read about percentage points. So that's a much more helpful number. So how do we get rid of the square? We take the square root, and that's what brings us to standard deviation. Standard deviation, as we discussed earlier, is measured in the same unit as the measure of the variable. In order to revert back to that unit, the standard deviation is measured by taking the square root. As a result, we get that very helpful descriptive statistic for the practitioner. Now, the average variability is, instead of 22.72 percentage points squared, the average variability is 4.76 points squared. And now we can see this kind of adjusted right up on the example. I'm going to enlarge this for you. But before, as we had seen, between Class A and Class B, the means, medians, and modes had all been the same, but now, here we can see the variability for Class A was pretty small, 22 percentage points squared, versus Class B, which had that huge range from 48 to 100, has a much higher variance. Then, if we look at that range, just the high minus low, a 58-point range versus a 12-point range. And if we look at the standard deviation, you can see an average variability of 4.7668, or what we calculate is 4.767, and then the variability in Class B, which was a lot higher, of 18 percentage points. Now, how you interpret this exactly, we're going to discuss in class, but this is a good starting point for you.